morning, Machine Con. Thanks for having me. I'm Will. As we mentioned earlier, I lead our product management and design functions at Fiddler AI. And I'm the third of 3 sessions to talk about agentic things. So I want to thank my first 2 co-speakers here for laying out a little bit about what agents are and sort of some ways to think about architecture. I'm going to come at it a little bit more from a builder's point of view. I know all of you are now increasingly working with developers. You may be developers yourselves. How are these systems actually built? How do you understand if they're working? And what do you want to consider? That's sort of our goal today. But first and foremost, let me just reinforce a couple things that we've already heard today. This is a big, exciting / scary graph that says, in the next couple of years, we have not seen sort of this transformational change since probably cloud, right? This idea of actually a technology pushing a paradigm shift for how business is gonna do better, we haven't seen this in a very long time. And the reasons why are really on the right? Is that both the internal processes as well as new products that we bring to market are gonna need to leverage these technologies in order to win. We're rethinking and reinventing all of the things that we're making. So, in order to do that, 6 months ago, all of your experiments might have looked a little something like this. One shot, single turn, really easy, right? Let's take our customer knowledge base that we've been putting out there with articles for 10 years, dump it into a RAG pipeline, and let's just make a chatbot for our customers, right? I'm sure all of us here have maybe at least considered trying it if you haven't already done it. That's not what agentic systems look like today and where they're going, right? They look a whole lot more like a graph. We're starting to see different players, agent-to-agent interactions, multi-turn architectures, and that actually makes things exponentially more complex. How do you hand off from one agent to another? What are the jobs of folks, right? As we mentioned earlier, what does it mean to actually have these sort of tools work together and win? This is now a big question that we have to think about. Specifically, if you think about how we build software right now, we at least know the paths. And this is why we need engineers so deeply, right? Because it's really complex to write all these hard-coded, heuristic kinds of logic into our software today. That is changing as we go to agentic, but it comes with its own challenges. It's non-deterministic, right? Even when you have a perfect path of how your app is supposed to work, you can't guarantee that your app is gonna take the same path every time. You can on the left. So what does that mean for the tools that we're gonna need in order to understand if our app is performing well, if our app is doing what we expect it to do, or better, if it does something we don't expect it to do, but it's an improvement on what we told it to do today? Well, let me give you guys an example. Imagine we're running a travel agency together, okay? Now, we've heard some of these use cases, but I'm gonna try to bring them to life. So up here in the blue, you might imagine different sessions, right? We all came here from different places. I came here from San Francisco. It was a pain of a flight, but that's okay, right? So if you want to arrange that, right, and you want to use Expedia to do it, there's a lot of code, huge code base to go make that happen. With an agent, it looks different. I just say, hey, I need to go from SF to New York. Figure it out for me. But what does figure it out mean? It might start with a supervisor, has a bunch of different actions that we've prompted or maybe fine-tuned to make that happen. But underneath, there's a whole fleet, a whole workforce, as we talked about earlier, in order to make that happen, right? And the interesting thing is, they might be working in parallel, they might be working together, they might not be working together at all. And so what does it mean when a flight agent is looking at booking times, but a hotel agent is concurrently looking at that? Are they talking to each other and looking at the same windows of availability? Are they working together to actually bring those answers and aggregate them back to the supervisor so that we can suggest something together? This is something that humans know how to do, right? We have 2 tabs open, we look at it, we're naturally comparing, but software doesn't normally do this without a lot of hand-holding. So what does it mean for agents to be able to do that? That's the big question. And if you look a little bit closer as well, these are not all just LLMs, right? Again, this is something that we've been talking about a little bit. LLMs and reasoning agents are at the heart of what I'm talking about today. But there's also core application actions, right? MCPs might be calling APIs and going to take actions. You might be getting 200s, 400s, 500s, right? You may have other systems. You may have your predictive intent models trying to figure out what use cases your users are doing before you ever kick them over to an agent, right? So this blend of ML and LLM, application tool calls, all these things together, that's what makes an agentic system work. And that's where we kind of need to evolve the tools we use to observe all that's happening in a particular session and actually start to aggregate them over time so we understand if our app is performing well. So, when we say on the left side, anyone who's used a Datadog, New Relic, Dynatrace, those kinds of things, that makes sense, right? We just want to see the distributed traces, how this all works, all the different servers that I'm calling or the different kinds of information that I'm accessing. Well, on the right, this is what a lot of the folks on the data side of the house have been doing for a long time. Let me understand my model performance. Is my data drifting over time? Am I hallucinating between my context and my output? Am I understanding how the models themselves are behaving? Well, it turns out these guys that build these tools really well don't know anything about that. And a lot of folks that are doing ML and LLM ops don't know anything about how apps work. The truth is, you need one app that comes together and actually sees all of that and presents it to you in one session. Because the last thing you want to do is be in what we call a swivel chair environment, where you're trying to say, okay, over here, this is how my app works. I had a broken call, let's figure that out. Whoop, swivel over here, how does my model work? And try to cobble that all together in a Tableau dashboard. Good luck, that's not gonna work, right? So what are some examples of the data that we need to make sense? On the left-hand side, I mentioned, we want to think about things like latency, response times, error rates, right? And again, if you are a data science or an MLA team, you may not have ever done this before. You don't know DevOps, or you don't know software engineering, right? On the right-hand side, we need things like hallucination, quality, right? Model bias testing, all the things that are actually hallmarks of data scientists, probably a Python package that you're running somewhere. This is something that your software engineers will look at you with a blank look in their face, right? So when you can combine those, you get a couple interesting things. You get hierarchy, and I'm gonna show you what that means in a moment. But in other words, all the components that I showed you in that travel agent example, they don't come for free. Hotel logs don't do that. So I'm gonna tell you how to actually detect those things. And more importantly, now we can start thinking holistically and saying, what does it mean to have mean time to resolution? How much of that was caused latency from my API? How much of that was caused by 3 recursive loops of my supervisory agent burning a bunch of tokens, trying to figure out what the user's trying to do? You need both of these kinds of data, application performance management and model performance management, to come together in order for that to win. All right, so in other words, figure out why, don't just figure out what's happening. Okay, so now that I've kind of illustrated the problem in front of us and why our existing tools don't necessarily solve the problem, I'm gonna talk to you a little bit about how we think about it at Fiddler. The first thing is, there's a couple new kinds of metrics or things that we want to think about measuring for these kinds of agentic systems, right? Now, these are a couple of buzzwords. I think a lot of people are going to get the resources, so I'm not going to talk through each one of these. Instead, I'm going to show you in context. So think about this. This is not an architecture, by the way, but this might be a journey of what your agentic app goes through in order to make sense of things. First, you might want to say the initial thought, right? Processing the inputs. What the heck is going on? What's the user asking me to do? And actually make a plan and reason, right? Before I go take action. From there, I execute that plan, whether it's planning that flight in that hotel, or it's actually coordinating with my work calendar to make sure I'm available for those things, right? There's a lot of things that are happening for my agent. But interestingly, here's a piece where today's software doesn't do this, and we really need it in an agentic system, which is reflection. There's actually a capability for your software to look at its own output and say, does this make sense? Is this what I expected it to do? This is much more than unit tests, right? This is actually that original supervisory agent saying, you know what, did I collect the credit card information? Did that go through? You know what, does it actually make sense that the hotel is out and the flight is good? Should I say that this is done or not? That kind of reflective pattern is really interesting. Because again, in traditional software, we don't want recursive loops, but in agents, we love them. The only downside, you're burning tokens, so watch out for cost, right? Now, if you could do all of those things, here's what's interesting. You can start creating business rules for what you expect need to happen, right? Small language models, whether it's built in-house or you're leveraging new sort of cloud providers, doesn't matter. You may have rules that say something like toxicity. If you guys are working in regulated industries, you want to make sure that people aren't feeding weird things into your customer service bot and trying to hack your system, right? You want to look for jailbreaks. You want to look for, again, hallucinations on your own side, where you're confidently incorrect in the answers that you're giving compared to your own source of your article, right? So the ability to do that in real time in a guardrail between the input and output of your agentic system really, really matters. So this is the journey that you want to think about and make sure that on each step of the way, we're measuring what matters. Here's a couple examples of those things. Again, this is a bullet point bomb, so I'm not going to read all of them to you, but these are actually the different categories that I was just talking about, right? You want to think about, wait a second, do I have an anomaly in my reflections? Is this app suddenly thinking a lot harder in certain use cases than other ones? Why is that? Is my prompt not strong enough? Should I add more context up front so that it's a more efficient thing? It's a less costly run. We haven't been able to do ROI per customer interaction like this probably ever in software, which is a lot and really exciting. Similarly, for tool execution, did you actually hit that calendar app properly? Did you hit your own intent model properly, and did you get the payload back that you expected? Did this work? You should know, right? So as you kind of go forward here, and especially when you think about multiple agents interacting together, did they follow the patterns that you thought you would, right? Now we're beyond one particular session. Think about over 100 sessions, or a 2-week look back, or something like that. What if I showed you your path analysis? Out of 100 different sessions you made, what are the most likely paths that your agents took? And what were the anomalies? Some of those anomalies might be aligned with the metrics that we expected, right? Burning more tokens, taking more time, timing out on the user, et cetera. But you know what? Agents have the capacity to surprise positively too. There actually may be pathways that they discover that were more optimal than you designed the app for, right? It may actually figure out, you know what, instead of asking where would you like to go today, we should actually ask you, what's your availability? Can I get your calendar first? And those are the sessions that have a higher chance of succeeding, right? Observing agents is like observing a workforce. Just like you have smart people and they tell you what to do, over time you can observe your teams, agentic or human, and they start showing you optimizations on the tasks that you've given them. That's the idea here. Okay. So, what are we doing at Fiddler then? I mentioned we're an AI observability company. For anyone who doesn't know what that means, we've been around, we're Silicon Valley based. We've been around for 5 or 6 years, and we got our start in model level observability. So helping you understand how predictive models like fraud, underwriting, computer vision, how all those things work, right? Data and context drift, performance, accuracy, recall, et cetera. And over time, our customers have pushed us towards what I'm sharing with you right now. We're noticing that rather than DS or MLE teams coming to us saying, how do we get developers to use our stuff? It's the other way around. The floor now has lowered a lot, and developers are saying, I love this, I just don't know anything about it. Can you give me new tools that measure everything that we've been talking about? So, a couple things for us here. This is what we look like today. Now, in addition to observability tools and analytics like charts, dashboards, root cause analysis, those kinds of things, we actually have our own in-house models as well, where we measure some of those things I told you about: toxicity, jailbreak, performance, faithfulness. Fiddler actually brings those things to the table as you're feeding logs into us, so we actually calculate that on your behalf. You can use them as metrics to actually measure your app and your performance. And that unlocks these kinds of use cases that we talked about, right? Now imagine that we're running in the background for you as your apps are producing logs. We'll actually alert you when those anomalies happen. We pull you in. So we're operationalizing AI, right? Again, as my fellow speakers spoke about earlier, there's lots of things you have to think about. Governance, performance, making sure that you're sharing this out with your board. Fiddler is the kind of tool that actually helps you do that, both as teams that are operating, as well as sharing it with executive boards, right? So underneath all of that, of course, we're pretty flexible. Again, this is not a commercial, just letting you know how we work right now. We are also cloud and on-prem. So the reason why I mentioned this is because of that security aspect. We know for a lot of teams, this data, how rich this isn't the same as sort of over here, you have a lot of applications acting and your databases are over there, safe and not accessed, right? These logs actually contain the data that we care about. So being able to deploy on-prem in your hyperscalers, in AWS Bedrock, Google Vertex, Azure Foundry, et cetera, is really important. So that's where we live. All right, so let's get back to the action. What do we actually need to measure? What do we need to be successful? We want to think about 3 things, right? Number 1 is just the visibility. You can't improve what you can't measure. So everything I showed you before that was diagrams, we make that real. We take the exhaust data of your inference logs, your OTel logs, et cetera. We structure it to make it real. Then we actually help give you the tools to detect and debug issues and go fix them, right? When those scores are low, when they change over time, when you see standards of deviation, we want to let you know that and go fix them and change them. And finally, we want to give you those insights at the system level over time and understand how to tune and improve your apps and make sense of them. So I'm going to skip this because we already talked about architecture a little bit. Let me show you a couple examples of what we need to do in order to make this happen. So we talk about cross-agent visibility. For anyone who's already built an agentic app, you may be familiar with the term OTel. You get logs at the event level, right? These logs don't tell you how all those different components in the system work, how that rolls up into spans, how that rolls up into traces on each session, which agents perform the actions. We actually look at your logs and help you figure out what is the architecture of my app, which things actually got lit up on a session-by-session basis, right? That's what we're building right now. And when you can do that then, you can start looking at the scores I mentioned earlier, the metrics that I showed you, and start to say, on what dimensions am I performing well? Am I doing really well on cost because these are really short, but doing terrible on performance because I'm not actually getting the outcomes that I want? Or is it vice versa? Is my app technically working, but it's crazy expensive because I'm calling OpenAI 8,000 times per session? I need to know that, right? And finally, when we do that well, you can think about that path analysis that I talked about. You can think about component failures over many apps. That scheduler that I mentioned earlier, you might be using that in multiple use cases or apps across the board, right? You need to be able to look at that in aggregate. So that's what we're building as well. And finally, if you can do that well, then you start being able to visualize how your app works. At the top, you might actually see your supervisor agent in parallel kick off 3 agents, and those are different tools underneath that call it. We'll intelligently visualize this for you, allow you to explore it, and actually show you the information about it on the right. So these are the kind of tools that allow you to bring to life all the concepts that I was talking about today, right? If you want to be able to see what pieces of my agentic app architecture are working well and not, you need a tool that understands it, can interpret it, and show it back to you without you having to manually structure that every day. So that's the summary here. When we think about what we need, what kind of tools we need to build the agentic apps of the future, we firmly believe that's what observability means. And that's why we say agentic observability is different and a key tool, right? Unlike model observability, where it's mostly useful after you're in production, after you've run data for a while to go see patterns, these tools are helpful in building your systems from the ground up before you release it to any customer. You need to say how things are doing. As you swap out different model providers, different prompts, different configurations, you're gonna wanna evaluate those and see how they work side by side. So that's the idea of what we're doing here and what we'd like to sort of bring to the industry and make sure that as you're building, you have one app instead of swiveling around to say, how is my app doing? How are my models doing to build agents? And that's it. Thank you guys for your time. If you have more time this afternoon, come see us downstairs. I'd love to talk to you about what you're building. All right, thank you everyone.